In this example, we lay out key poses for a character squatting. Here's the output of our model, which produces a realistic transition. Here we overlay our model's generations over 8 different seats. We generate diverse timings in the second squat. Here we overlay prior work CondemnDI's generations over 8 different seats. The generations are jerky, and aside from shifts in wrist and neck position, are much the same over all seats. Given this original motion of a character kicking, we want to add a second kick. Let's replace the pose on the left with the pose on the right, where the right leg is fully extended again. Here's the input constraints to our system, some context from the original motion, and the new kick. Our model creates a detailed, well-timed transition. In this example, we lay out key poses for a character jumping rope. Each key pose is a foot plant. Here's the output of our model, which produces bouncing steps. Though our model was trained on 60-frame motion clips, we can handle arbitrarily long motion by extending Tseng et al.'s in-painting procedure. Here is a much longer version of that jump roping sequence. We show some qualitative comparisons to ablation's no time and IMPC. Given these input poses of a person walking and doing arm circles, our model adds details like steps and arm swings. Our ablation no time cannot make enough time between input keyframes to complete the circles. Imputation-based technique IMP0 results in huge discontinuities. IMP1 produces a smoother motion, but it is unrealistic and misses keyframes. IMP5 produces an even smoother motion, also at the cost of keyframes and realism. Given these input poses of a person kicking then ducking, our model adds details like weight shifts and the kick. Our ablation no time produces an implausible transition between kick and duck. Imputation-based technique IMP0 results in huge discontinuities. IMP1 produces a smoother motion, but it misses keyframes. IMP5 produces an even smoother motion, also at the cost of keyframes and realism. We show our results on a few example motions randomly sampled from the test set. Here are the 3 keyframes and our generation. Here's another example, 3 keyframes and our generation. One might ask, can you use imprecisely timed keyframes as input to a motion in-betweening method like CondemnDI, then manually retime the generated motion? Recall these keyframes from earlier in the video of a person dancing. Given those keyframes, CondemnDI generated a jerky, unrealistic motion with a misstep due to the imprecise timing. We tried manually creating time warps that would make this motion look like the one we wanted, but this was highly non-trivial given all the missing spatial detail like a misstep. Here's an example manually warped motion with a manually created time warp in the bottom right. Our goal with the time warp was to try and smooth the jerkiness and recover the missing step, but we found this very difficult and weren't successful. Here's another attempt. We again were not able to manually construct a warp that would recover the missing spatial detail. Here's another attempt. We again were not able to manually construct a warp that would recover the missing spatial detail. Learned in betweening from imprecisely timed keyframes can create a motion lacking correct spatial detail, which is difficult to recover with manual retiming.